We're going to kick it off with Adam Carmi talking about large-scale automated visual testing.
Thank you. Hi, everyone. I'm Adam Carmi. I'm the co-founder and VP R&D of Applitools. We're a company that provides a cloud service for automated visual testing. Large-scale automated visual testing is a reality today. There are teams that are running, executing thousands and tens of thousands of visual tests on a daily basis. And this talk will focus on the key tips and guidelines that are crucial to succeeding with visual testing at this scale. So for those of you who are not familiar with visual testing, I'll start with a brief introduction. I'll explain what visual testing is and why it should be automated. I'll also explain how automated visual testing tools work. And the remainder of the talk will focus on the scale-up tips, and we'll have time at the end to answer any questions that you may have. So what is visual testing? It's a quality assurance activity aimed to verify that a graphical user interface appears correctly to users. Now, this goes beyond the traditional functional testing that you used to do with tools like Selenium and Appium, where you test the functionality of the application through the UI. What we're focusing on here is making sure that the UI itself appears right and correct to the end user. We want to make sure that each UI element appears in the right color, shape, position, and size, that it doesn't overlap or hide any other UI element. This type of testing has become increasingly difficult to perform in recent years, mainly due to the explosions of browsers, devices, operating systems, and screen resolutions that applications are expected to run on today. So here you can see an example of a visual bug that we found in the Microsoft Azure Management Portal. You can see here how the graph exceeded the expected bounds of the page. And this is how the Amazon website looked like for several hours for some customers during Amazon Prime Day 3 months ago. So I'm sure you've all seen these type of bugs, and maybe in your own application, and you understand their severity. They can be very embarrassing and damage the brand of the company. But in some situation, they can completely cripple the functionality of the application and end up costing a lot of money, which is probably what happened in this case. So why should we automate this type of testing? There are many reasons, but the most important one is that the test matrix is just too big to cover manually. Think of all the different web browsers, devices, operating systems, and screen resolutions that your application is expected to run on. We all know that a website that looks good on Chrome doesn't imply that it looks good on IE, and an application that looks good on a widescreen doesn't mean that it would look good on a smartphone. So we have to test our application in all these different environments, which can be very ineffective and costly to do manually. If your application is responsive, and most modern applications are, then you also need to test all the different layout modes in all these different environments. If it's localized, then you also need to factor in the fonts, resources, images, and content that is specific to each language. And of course, even if you don't change a line of code in your application, still you depend on third-party upgrades that can introduce visual bugs to your application. An example for that is a web browser that updates every few weeks, and whenever it does, it can introduce incompatibilities with your website that may be manifest as visual bugs. So you have to test a lot of things many times, and it's just too ineffective to do manually. What makes things even worse is the fact that release cycles keep getting shorter and shorter. So companies that are doing continuous deployment today, which is the current hype, are releasing to production several times a day. And with such short release cycles, there's hardly any time to do any type of manual testing, let alone making sure that your application looks good in so many execution environments. So let's take a look at how these tools actually work. So there are many automated visual testing tools out there, and they all share the same workflow with these 4 simple steps. In the first step, you drive the application on the test and take screenshots. In the second step, the tool takes those screenshots and compares them with baseline images. These images define the expected appearance of the application. And in the majority of cases, these are simply screenshots that were taken in the past and approved by a human tester. In the third step, the tool generates a report following the test run that includes all the screenshots, all the baseline images, and any differences that were found during the test. And in the first step, tester has to look at the report if any changes were found and decide for each change if it's a bug, in which case he opens a bug, or if it's a valid change to the application, he simply approves the new screenshot to be used as a baseline images for subsequent runs. Here you can see an example of the first two steps, taking screenshots and updating them, with an open source visual test automation tool called WebDriver CSS. As you can see, JavaScript based, and it extends the WebDriver I/O WebDriver. And this test is very simple. You can see that it starts with the instance of the WebDriver I/O. It initializes it, which causes the browser to open. In this case, it would be a local Chrome browser. Then it navigates to the example.com URL. And then it performs a visual validation point with the WebDriver CSS command, which takes 3 parameters. The first is a name for the checkpoint. That's how it will appear in the report. And then a list of elements that you want to validate. In this case, there are 2 elements, header and hero, and they are both defined with CSS locators. And the third parameter that is a callback that is called if differences are found. There you can assert and make sure that the differences do not exceed any mismatch tolerance that is predefined. So you can see here how easy it is to take an existing functional test, in this case a WebDriver test, and just turn it into an automated visual test with a few lines of code. Here you can see an example of the 2 last steps, viewing the report and updating it with a tool called Gemini, also an open source tool. You can see here that you have a list of all the checkpoints. The one that has differences are marked in red. And you can see for each difference that is found that you have an image of the baseline. It's called reference in this tool, the screenshots that have been validated, and also a diff image, which is basically the screenshot with all the different pixels highlighted in pink, so it would be easy to identify the change. And the maintenance operation that you need to do if you decide that this is not a bug is just click this button over here, the arrow, and this would replace and set the screenshot as the baseline for subsequent runs. There are many visual test automation tools available, so if you want to get started with them, you have a lot of options to choose from. It is important to highlight that the majority of tools, all of them almost, only work for websites. They won't work for mobile applications. The only 2 exceptions are Facebook Snapshot Test Case by Facebook that can test iOS applications, and Applitools Eyes that will work for any mobile application that can be driven with Appium. And that concludes our brief introduction to visual testing. Let's proceed with the scale-up tips. And the first tip is naturally use a robust image comparison engine. And if you'll allow me to quote Boromir, then one does not simply do bitmap comparison. And the reason you don't do it is that if you do it, is you get a lot of false positives. False positives in the context of visual testing is a case where the tool tells you that there's a difference, but you as a human being cannot see it, or it's so minute that you don't care about it. And there are many, many reasons for this, these false positives if you're just doing simple pixel-to-pixel comparison. And let's take a look at some of the most common ones. So the first one has to do with an image processing effect called anti-aliasing. And here's an example of it. You can see we have at the bottom of the image a navigation bar, and the playlist tab is magnified. You can see at the bottom that the playlist text appears in white. And probably that's what the color of the text was in the DOM or whatever. But you can see in the magnified image that actually many of the pixels are not white. They have different shades of blue. This is anti-aliasing at work. Okay, basically, the rendering engine, which is the graphics card or whatever is responsible for rendering this image, is painting certain pixel along the border of the lines in different shades and intensities and colors. And in order to make the text appear smoother to us. The problem with anti-aliasing is that if you run your test on several machines, which makes sense if you have more than one tester in your team, or if you're running your test in a lab, which makes sense if you are trying to scale up, is that you'll get different rendering engines painting those pixels, which means different implementations of the anti-aliasing algorithm. So this, for instance, is how anti-aliasing will look like on a different machine. I will toggle between the two, and you can see how different the pixels are. Not that different. How different they are in position and color. Then again, you need a very sophisticated image comparison engine in order to be able to identify that these different pixels are actually invisible to the human eye and just ignore them. Otherwise, your test will fail. A similar case has to do with pixel brightness when run on different machines, or even on the same machine, which is connected to a monitor with different capabilities. You can see how different the intensity of the pixels can be. This example has to do with the positioning of text. So this is, you probably recognize it, is the Dropbox website, and you can see that the upgrade account element is moving. The reason that it's moving is that to the right of it, there is a username, and whenever we run the test, there's a different username. It has different length, and because of that, the upgrade account element is moving. So we would still want to visually validate it. So one simple solution to this problem would be to just capture a screenshot of the upgrade account element and compare it to a baseline that just for that element. And so it doesn't really matter where it appears on the page. That's a very good idea, but if you're doing pixel-to-pixel comparison, it will still not work, because although it seems that the upgrade account element moves as a whole, actually each individual letter is positioned on its own. So you can see how the A and C and O letters are positioned in different pixels. And then again, you need the image comparison engine to be able to realize that all these different pixels are actually look the same to a human. The last example I'll show you has to do with Gmail scaling, which happens all the time in every application. What you see here is this car here and the small magnified box here. And what happens is that whenever you have an image element in your application, and the source image that it's showing is not exactly of the same size, the rendering engine will actually scale it so it would fit the target position. And then again, two different rendering engines would use a different scaling algorithm, and that would actually result with extremely different pixels, as you can see here. So again, extremely different pixels, but completely invisible to us as humans. And again, this is something that the tool needs to be able to take care of. And there's more. There could be arbitrary pixel offsets. Some could be small, like text or paragraph displayed at 1 pixel offset. Some could be more severe, like a column of a table being 1 pixel wider. And that would move the entire page 1 pixel to the side, resulting with a 70% pixel-wide change of the image, but still completely invisible to us. You need to be able to deal with dynamic content, such as dates and ads and usernames, moving elements like the upgrade account samples as we saw before, comparing images of different sizes. And of course, the image comparison engine has to be extremely fast, otherwise your test will take forever to run. And there are those that always get mismatches, and there's nothing you can do about it. But seriously, visual test automation tools have come very, very long way. They can very successfully handle this type of false positives today. But before you start working with a visual test automation tool, you need to make sure that it works very stable for your app. Because if you won't be able to get away from these false positives, there is no way that you'll be able to scale up your tests. Tip number 2, use a single baseline across devices and browsers. So the idea here is to reduce the amount of maintenance that you have to do, especially with regards to cross-browser and cross-device testing, by reducing the amount of baseline images that you need to maintain. And this is how you do it. You keep a set of baseline images for your application on for a specific execution environment. Let's say Chrome on Windows. And whenever you have a new release of your application, you use that same baseline to validate that new release on the exactly the same environment. Basically, you're doing visual regression testing. You can find unexpected changes. You can use a very strict matching algorithm to do that, because your application is running on the same execution environment, and so it should render exactly the same. Once you're done with that process and you have updated your baseline to reflect the new version, you can then use the same set of baseline images to make sure that your application renders correctly in other execution environments, such as other browsers, other devices, or form factors, by making sure that their layout or structure is consistent with that of the baseline. And I'll show you an example of this to clarify it using Applitools eyes. OK, so the first example is for a cross-browser test. You can see the baseline image here on the left-hand side and the screenshot that we're validating on the right-hand side. You can see that the baseline image was taken on Chrome, and the screenshot was taken on IE. If we toggle between the two images, you can see how different the browser renders these images. You can see that the fonts are slightly smaller or bigger. They change position. The text here wraps a bit differently. But when we're performing a structural comparison, all of this is fine. The images are consistent in terms of layout and structure. We have this radar button here that we can click to find any differences that we did find, and we can see that we have a difference at the bottom. If we zoom into it, we discover that we actually did have a missing element in IE. So this is an example of how you can use structural matching to find bugs between across browsers. The next example shows a cross-device test. This is Twitter on 2 different mobile devices. And we have 2 violations here. So the first one it occurs here. The baseline image dictates that the paragraph should be aligned to the right of the image. And this is broken here. Here at the bottom, we have an image, but it is missing in the screenshot. So again, all these structural changes can be caught. And if you see, when I toggle the screenshots, the 2 tweets in the middle, although they have different images and text in them, are not highlighted as different because structurally they are equivalent. Another very powerful application of structural or layout matching is monitoring and testing dynamic applications. So in this case, we have the Yahoo website, and the screenshot and the baseline were taken in a 24-hour difference. You can see how different the images are and the articles, but still, structurally, they are equivalent and no difference is reported. If I would change this to a more strict match, you can see that all the dynamic parts are highlighted and the fixed ones aren't. But if I would do pixel-to-pixel comparison on this page, you can see that actually everything is highlighted. And the reason is that everything here is different, only we cannot see it. And strict matching in this case is powerful enough to ignore all of that. Back to the slides. OK, tip number 3. Baseline maintenance should be codeless. In the majority of cases, maintaining the baseline involves looking at the screenshot and clicking a button to approve it as a baseline. In some rare situations, you also need to mark 1 or more regions on that baseline that are dynamic, and you don't want them to be matched during image comparison. So actually, there is no real value or benefit to doing this kind of maintenance in code. On the other hand, if you do it in a codeless way, there is a huge advantage. First, everyone in your team can do it, even those members of your team that don't know how to code. More importantly, they can do it immediately when they see the change. So just think about the huge difference if you have hundreds of baseline images to maintain, and when you see a difference, instead of just clicking a button and accepting it, you need to open up an IDE, find the test code related, change the code there, and making sure you don't introduce new bugs. Or even worse, find the guy responsible for the test, open a ticket for him to fix the test. It could be a difference of hours and hours of work for every test run. There's another mini tip here that is a bit counterintuitive, and it is to prefer full page validation over element-specific validation. The reason this is preferable is because it's allows you to avoid maintaining those element locators in code that tend to break when the UI changes. Tip number 4, maintain at the test suite level rather than at the test level. Now, this seems a bit trivial, but actually it's a very important tip. There are situations with visual testing where there is one bug or one change in the system or very few changes that are captured by multiple checkpoints across many of your tests. Just think how frustrating it would be if you would have a build that fails and the report would show you 200 tests that have failed, and now you have to go over one by one, choosing the first test, looking at the difference, resolving them, going back to the list, looking at the next test, and so on and so forth. What is much preferable is just to see all the changes that happened during that build and immediately have the ability to resolve them and completely ignore the tests. In fact, what you would really want to have is the ability to see only the unique changes and not all of their occurrences. And this leads us to the final tip, which is automate your maintenance. And in order to explain to you what automated maintenance means, I'll show you another demo with Applitools eyes. Another demo. Great. So for the purpose of this demo, I prepared a small test suite for the GTAC website. And I ran it. I created a baseline. I simulated the difference. And then I ran it again. And let's see the results. So in this case, we see that the test suites, or batch as we call it, is called GTAC. It ran, and it appears as red, meaning that it found differences. A small summary here tells us that there were 28 tests there. They covered 3 environments. Those would be IE, Firefox, and Chrome on a Windows machine. 3 form factors that correspond to the 3 layout modes that the website supports. It's a responsive website. And in total, we had 91 checkpoints that all of them found differences. So let's look at the first image, click the radar and see. And we can see that we have a small difference here at the footer. Let's zoom in and see what we found. We toggle between the images, and we see that we have a plus symbol that changed to a minus. So let's assume for the sake of the demo that this is not a bug, but actually it's a rebranding of the product. and so we want to approve it. But before we do, let's look at the other images. So we look at this one, and oh, it's the same place. It's probably the same change, right? And this one, oops, let me go back here. And this one, probably the same. And this here, this one at the bottom, again, the same. So, but it makes sense, right? We just changed the name of the product. It probably appears in all the images. So we are really tempted to click this button that says accept all. I'm not going to do that. I'm going to click on another button. And I'll explain why I'm not clicking that button. Accept all basically means override the baseline with all the screenshots that I found. And all the visual test automation tools allow you to do that. But actually, it's a very dangerous thing to do, because what you're actually doing is skipping maintenance. So you could introduce bugs, real bugs, into your baseline and then prevent the tool from finding them later on. So if I was free to choose a name for this button, it would be skip maintenance, and the tooltip would be I'm too lazy to do my job. Basically, what I just did is I asked the tool to do this maintenance operation for me in an automated way. I asked it to find all the similar differences. And the result is that from this build that had all these failures, I only have 2 images to look at right now. 90 of the checkpoints have exactly the same change. Although they ran on different browsers and they ran in different layout modes and form factors, still a plus changed to a minus, and that's it. So I can just go ahead and approve that because that's what I want to do. I have another change here, and let's see what we found here. And although it's subjective, I think that you can agree with me that we found a bug. And so we won't accept it, but reject it. And with that, we're done maintaining our test run. So there are many opportunities with visual testing to do this type of automatic maintenance. As you can realize, it goes a very long way in allowing you to scale up your test without introducing more overhead to your maintenance. And with this, I conclude my talk, and I hope that you learned something new and enjoyed it, and I'll be happy to take your questions now.
Well, thank you, Adam. You have earned your free lunch by finding bugs on our website.
Yeah.
So for the first question, how does your baseline strategy work in a continuous build and release model?
So basically, it would work like it has nothing to do with a continuous release or build model. So basically, you run the test, there are failures, you look at them. If there's a failure, you don't release immediately. You wait until someone approves it. So it's basically, it fits right in there. And it's actually the safe way to do continuous deployment, because instead of just releasing stuff without looking at it, you know when there's a change.
How do you minimize the cost of writing and maintaining a new set of tests?
So there are different strategies that different teams use to do visual testing. Some would write new tests, very simple tests that just browse through the application. If it's a website, usually they'll just put in a set of URLs of a few lines of code, and it will just go over the entire set of pages on all the different execution environments, and you're done. Other teams will take their existing tests and just add validation points where they want to. And others will go to their test infrastructure. Usually you have some kind of abstraction around the test driver, and you would just hook it into some operations that would automatically trigger validation points. So one of the best practices is to do a validation point immediately after you change to a different URL. And the other one is just before you click a button or a link. So that covers like 80% of everything you need, and it's just centralized at one place, and you're done, and you have full coverage for whatever test you already have running.
So how would you use the tool to test a website or mobile app that has not yet launched? Can it be run locally?
So basically, if you're asking, if the question is specific for Applitools or for any other tool, so what's interesting? OK, so basically, the open source tools, all of them, they run locally, so there's no problem using them locally. With Applitools specific, then we support on-premise deployments and also private cloud and public cloud deployments. But anyway, the test always runs behind the firewall. So there is no need to open up tunnels from the outside into your organization. We use, for instance, with Selenium, the WebDriver to get the screenshot, and we send them outside. So if you can Google out of your test machine, the machine that is running your test, then you can work with the service. You don't need, it can be behind the firewall.
Changing order. What's your diff engine? Is it public?
The diff engine is something that we've been working on for more than 3 years today. It's not public. That's our secret. We don't patent it as well, so we don't need to expose it. It's not open source, and there is nothing out there that we build on. It's completely from scratch to handle this type of work.
Do you use these tools as acceptance tests rather than as tests to find bugs?
Using this tool as an acceptance test is a very, very effective way to work with the tool, by the way. If you don't want to bother yourself with each build and update the changes, although this becomes an amazing collaboration tool in the team, because immediately you see everything that changed, not bugs. Even if your PM doesn't like the color of the button that the developer just changed a minute ago or 10 minutes ago, we can immediately give him this feedback. But if you don't want to do that, then you can just use it as an acceptance test, run it once before you listen to production, or use your staging environment as a dynamic baseline to match your new candidate to test it, make sure there are unexpected changes. That would be a great way to do it. So for acceptance testing, that's great. What was the other one? I forgot. Where is it?
I don't know that there was more to that question.
No, I think there was, but I feel there was, but I don't remember.
Okay. Sorry, we just.
No. Okay. No problem.
What about false positives? For example, things are expected to be different visually across runs or browsers or platforms.
then you can just have a different baseline for each of them. So that's fine, no problem.
Cool. And we are out of time, so thank
Okay.
you, Adam.
You're welcome. Thank you.